Division of line segment. In this module, we will introduce how to divide a line segment. Suppose a line segment is given and you have to divide it in a given ratio, say 3:2. You may do it by measuring the length and then marking a point on it that divides it in the given ratio. But suppose you do not have any way of measuring it precisely, how would you find the point? Let us see. Construction. To divide a line segment in a given ratio. Given a line segment AB, we want to divide it in the ratio m:n, where both m and n are positive integers. To make it clear, we shall take m = 3 and n = 2. Steps of construction. 1. Draw any ray AX, making an acute angle with AB. 2. Locate 5, that is m plus n points A1, A2, A3, A4 and A5 on AX so that AA1 is equal to A1A2 is equal to A2A3 is equal to A3A4 is equal to A4A5. 3. Join BA5. 4. Through the point A3, m = 3, draw a line parallel to A5B by making an angle equal to AA5B at A3, intersecting AB at the point C. Then AC is to CB is equal to 3:2. Let us see how this method gives us the required division. Since A3C is parallel to A5B, therefore AA3 upon A3A5 is equal to AC upon CB. By the basic proportionality theorem, by construction, AA3 upon A3A5 is equal to 3/2. This implies AC upon CB is equal to 3/2. This shows that C divides AB in the ratio 3:2. Now let us construct a triangle similar to a given triangle whose sides are in a given ratio with the corresponding sides of the given triangle. Construction. To construct a triangle similar to a given triangle as per given scale factor. This construction involves two different situations. In one, the triangle to be constructed is smaller, and in the other, it is larger than the given triangle. Here, the scale factor means the ratio of the sides of the triangle to be constructed with the corresponding sides of the given triangle. Let us take these examples for understanding the constructions involved. Example: Construct a triangle similar to a given triangle ABC with its sides equal to 3 by 4 of the corresponding sides of the triangle ABC, that is, of scale factor 3 by 4. Solution. Given a triangle ABC, we are required to construct another triangle whose sides are 3 by 4 of the corresponding sides of the triangle ABC. Steps of construction. 1. Draw any ray BX making an acute angle with BC on the side opposite to the vertex A. 2. Locate 4, the greater of 3 and 4 in 3 by 4, points B1, B2, B3 and B4 on BX so that BB1 is equal to B1 B2 is equal to B2 B3 is equal to B3 B4. 3. Join B4C and draw a line through B3, the third point, 3 being smaller of 3 and 4 in 3 by 4, parallel to B4C to intersect BC at C dash. 4. Draw a line through C dash parallel to the line CA to intersect BA at A dash. Then, triangle A dash BC dash is the required triangle. Example. Construct a triangle similar to a given triangle ABC with its sides equal to 5 by 3 of the corresponding sides of the triangle ABC, that is, of scale factor 5 by 3. Solution. Given a triangle ABC, we are required to construct a triangle whose sides are 5 by 3rd of the corresponding sides of triangle ABC. Steps of construction. 1. Draw any ray BX making an acute angle with BC on the side opposite to the vertex A. 2. Locate 5 points, the greater of 5 and 3 in 5 by 3, B1, B2, B3, B4 and B5 on BX so that BB1 is equal to B1 B2 is equal to B2 B3 is equal to B3 B4 is equal to B4 B5. 3. Join B3, the third point, 3 being smaller of 3 and 5 in 5 by 3 to C, and draw a line through B5 parallel to B3C, intersecting the extended line segment BC at C dash. 4. Draw a line through C dash parallel to CA, intersecting the extended line segment BA at A dash. Then A dash BC dash is the required triangle. Construction of tangent to a circle. In this module, we will discuss the construction of tangent to a circle. We have already learned that if a point lies inside a circle, there cannot be a tangent drawn to the circle through this point. However, if a point lies on the circle, then there is only one tangent to the circle at this point, and it is perpendicular to the radius through this point of contact. Therefore, if we want to draw a tangent at a point of a circle, simply draw the radius through this point and draw a line perpendicular to this radius through this point, and this will be the required tangent at the point. We have also seen that if the point lies outside the circle, there can be maximum 2 tangents to the circle from this point. We shall now see how to draw these tangents. Construction. To construct the tangents to a circle from a point outside it. We are given a circle with center O and a point P outside it. We have to construct the 2 tangents from P to the circle. Steps of construction. 1. Join PO and bisect it. Let M be the midpoint of PO. 2. Taking M as center and MO as radius, draw a circle. Let it intersect the given circle at the points Q and R. 3. Join PQ and PR. Then PQ and PR are the required 2 tangents. Now let us see how this construction works. Join OQ. Then angle PQO is an angle in the semicircle, and therefore angle PQO is equal to 90 degrees. So we can say that PQ is perpendicular to OQ. Since OQ is a radius of the given circle, PQ has to be a tangent to the circle. Similarly, PR is also a tangent to the circle.